Hey guys, still talking about linear equations here, but this is a quick video to talk about direct versus partial proportionality. Now, a lot of people would talk about these two separately, but I think it's important for us to compare and contrast. And I'm going to do that by talking mostly about this guy, bananas. So I'm going to go to a store and I'm going to buy some bananas, and we're going to demonstrate direct versus partial proportionality doing that. Now, you guys hopefully realize, or may not realize, that bananas are usually sold by the kilogram. So you might say the bananas are $2.50 per kilogram. Okay, so if you buy 0 bananas, you pay $0. 0 bananas, $0. Makes sense. If you buy 1 kilogram of bananas, you pay $2.50. If you buy 2 kilograms of bananas, you pay $5. You guys are smart enough to figure this stuff out. Of course, we could graph this pretty simply by using the function. We can graph this pretty simply by using the function y equals 2.5x. So you can see that 1 kilogram of bananas will cost $2.50. 2 kilograms of bananas will cost $5. 3 kilograms will cost, it's just up there a little bit, $7.50, and so on and so forth. So that's pretty straightforward so far. The important thing to note about this is that if you buy 0 bananas, it will cost you $0. Why am I stressing this point? Because that is what direct proportionality is. If we want to talk in purely mathematical terms, it passes through the origin. And lots of things are directly proportional. Let's say time driving in my car versus distance from my house, provided I started at my house. If I've spent 0 time driving, I'll be 0 kilometers away from my house. As soon as I start driving, I'll be some amount of kilometers from my house. That's direct proportionality, as long as it passes through the origin. Now let's consider partial proportionality. Pretty straightforward. It's still a linear equation, but doesn't pass through the origin. Now, we can still shop for bananas using this, doesn't pass through the origin. But this time, let's talk about all of the costs associated with going to buy bananas. So, unless you walk to the shops, you'll drive to the shops, which is going to cost you in fuel. It's also going to cost you in wear and tear on your vehicle. If you have to pay for parking, you'll also have to pay for parking. You haven't even stepped into the fruit store yet, or Coles or Woolworths, and it's already costing you money. This is what we mean by partial proportionality. If we were to graph that, it would look something like this. Let's say it costs $4 for fuel to get to the shop, and let's say it costs $3 for parking. That means that before you've even bought a single banana, it's going to cost you $7. Let's take a look at what that looks like on our graph. Y equals 2.5x. There's still our cost of bananas, but the fixed cost that goes with it is the plus 7. That's our C value. So you can see that if you buy 0 kilograms of bananas, it's still going to cost you $7. That's a very expensive kilogram of bananas, or at least in this world it is. If, however, you buy 1 kilogram of bananas, it'll cost you $10. $9.50. 2 will cost you, you guys can figure that out for yourself. You get the basic idea here. Direct versus partial proportionality. What does this mean for you? It means that if you are graphing a partial proportionality, it's pretty simple because it has an x and a y axis. So if I give you an equation that's a partial proportionality, you can use the x and y intercept method to graph it. Find the x-intercept, find the y-intercept, join them up. However, if you are given a direct proportionality to graph, you're going to have to be a bit smart about it because it only passes through the origin. So the x and the y-intercept are the same, so you can't use the x and the y-intercept method to graph it. You're going to have to do something a bit smarter than that. You'll know that it passes through the origin, and then you'll be able to use the gradient to find a second point, what we would call a significant point, somewhere over here. That's called the intercept gradient method, or the point gradient method of graphing. But I'm getting away from the major point here. As long as you know what direct versus partial proportionality is, you'll go far. All right, that's direct versus partial proportionality.